Hello everyone. Today we will look at a small case study on the integration of quality function deployment, virtual engineering, and the design for manufacture and assembly. This we will try and do it for the product design stage. So let us look at this is actually a published paper, and then we are trying to analyze the case study. Okay. During the design stage of significant amount of information is gathered and analyzed to support the decision making process. Okay, so the decision DFMA is one way where we can try and then bring down the cost. Many methodologies have been deployed to collect, organize, analyze, synthesize, and display the information in the design process. Okay, this case study is basically on the quality function deployment, value engineering, and the design for manufacture and assembly, and how they are all interconnected. This is what we are going to see for a few case studies there. Okay, so introduction, is more about the various analysis, etc. There. So the next one that we will try and see is that what is the kind of information that is useful as a design process involves through the use of quality function deployment, virtual engineering, and the design for manufacturer assembly. What is the information that is missing? What is a particular contribution of each tool to enhance the design process, right? So let us look at the literature review here. Um, Okay, so many people have worked on this, and so this paper tries to talk about the various other authors and their contributions for the design for manufacturer assembly. Now, they have tried to do an integration model here. This is a standard quality function deployment diagram where you try and find out as to what are the parameters which play a role in the function of trying to make the design. Okay, so and the value engineering, and then finally we have the design for manufacture and assembly. Now, since we are more concerned with the DFMA process, we will straight away jump onto the DFMA part of this case study. Now, the five, there are 4 or 5 cases. The 5 cases are there. Now let us look at it. There was a cable holder. Okay, now that cable holder, what has happened is that there was a system to feed the cables to the power distribution board, and the project originated in the sales department. Okay, what are the objectives to be done is that increasing market share by distinguishing the design characteristics and the product acceptance. Now, after the QFD was done and the DFMA was also carried out on that, the cost increased slightly, but the customer was not willing to pay more and complained that, and it looked at it as less robust because there were no bolts, etc. Okay. Now, so whether the bolts should be there and whether it should not be there, etc., is to be further analyzed and then brought out. The next one is to control handle. It's a control handle of a small contractor, uh, small tractor. Okay, and the idea is to reduce the cost. The design was simplified. The cost was reduced, and this is being used for implementation also. And next we move on to the oil pump. And in the oil pump for the automobile project originated in engineering, the number of parts were reduced. Manufacturing cost was increased basically because the new tooling was there. Okay, generally we understand that the manufacturing cost should not increase, but over a period of time, initially when the new tooling is there, it will increase, but then because of the number of parts, the overall cost of the product will come down. Okay, the floating joint switch which is there originated from engineering. The, the number of parts was reduced without the effect of the on function. The manufacturing cost was again increased here. Now, the AC motor control and the project originated in the customer service department to improve the reliability, and all the value engineering, the quality function deployment, and the DFMA was total, or all the 3 were used. Heat removal system was redesigned and the optimized DFMA was there. Manufacturing cost again increased, but the assembly cost was reduced even more. Reliability was not increased, but the serviceability was greatly enhanced, and it has been used for it has been brought for implementation. Now, what we should see is that, in all these things, they say that there is a manufacturing cost which is increased. We should not directly take that the manufacturing cost for the small tooling that we are trying to tweak, etc., for this small changes that we are trying to do as a cost. Initially, the cost will be there, but cost is generally should be calculated on how many parts were made and for how long period they have been. When you are going to break even the cost that has been incurred. So these are these are all the findings about the integration method, and the case study is there. On concluding, the QFT is capable of identifying functions and needs improvement for in the given product. That is what it tries to find out. Then the information of the QFT makes the value engineering process more focused and manageable. The DFME is used to optimize the design proposals, and the information on the QFD process can be used to evaluate the impact that the modifications or the suggestions by the DFMA analysis that may have on the product performance. So this is a small case study that we looked at how the quality engineering, the value engineering, and the quality function deployment, value engineering, and the DFMA, they all play a role in the product design process. Thank you very much. We will meet for another video later. Okay. Thank you.